Hello, hello. Here is the video going over the Unit 4 Systems of Equations portion of your Semester 2 final exam review packet. So the first thing we're going to look at are the different kinds of solutions that you could have with a linear system. So you could have one solution, and one solution happens when you have two lines that actually intersect. That intersection point would be your solution. No solution is when you have two lines that never intersect, and those are going to be parallel lines. And many solutions are when your lines actually overlap and they're sitting right on top of each other. So that creates an infinite amount of solutions. So that is what is outlined within this box over here. Just reminding you that solutions happen where lines intersect. Regions we'll talk about once we get to the inequality portion. Parallel lines have no solution. Intersecting lines have one solution, and the same line will have infinite solutions. So if I look at number 2, it says, what is the solution to this system? Since I do have my two lines already graphed, I can circle where my intersection point is, and I can actually write down what that ordered pair is, and that is at -2, 1. So my solution for that system is at -2, 1. For number 3, I'm going to graph each one of these lines individually. So I'm going to start with the first one, where my slope is the number in front of x, so my slope is 1, and my y-intercept is that 2, so 0, 2. So I'm going to start at 1, and my slope is 1, so I'm going to go up 1 over 1, up 1 over 1, and so forth. And then I can go ahead and draw my line going through those points. I can draw them very carefully. That way my line stays nice and straight. Use a ruler if you can, or a straight edge. For my second line, which I'm going to do in blue so you can distinguish between the two, my slope is 3 and my y-intercept is 0, -2. So I'm going to start at -2 on my y-axis. My slope is 3, so I'm going to go up 3 over 1, up 3 over 1, and as you can see, I landed right on a point on my purple line, so that is my intersection point. So here is where the solution is, and that ordered pair is 2, 4. So my solution for the system is at that intersection point of 2, 4. Number 4, the sum of two numbers is 78, and their difference is 12. What are the two numbers? So the first thing I need to do is I need to actually write an equation. But before I write the equation, I need to establish my variables. So x is going to be the first number, and y is going to represent the second number. So when I add these two numbers together, it gives me 78. When I subtract them, because it says their difference is 12, when I subtract them, it's going to equal 12. Now, you have some options for solving this. You can solve by substitution, elimination. You can go ahead and graph them. I am going to go ahead and solve this one by elimination. And the reason why I want to do elimination is because I notice that my y's have the same coefficient, the same number in the front, with opposite signs. So what happens is when I add my two equations together, my y's can go ahead and eliminate. 1x plus another x is 2x equals 78 plus 12 is 90. And then I can go ahead and continue to solve for x. I can divide both sides by 2, so I get x equals 45. And since I know that the sum has to be 78, I can go ahead and plug 45 in for x and use that to solve for y. So I can subtract y from both sides, I can subtract 45 from both sides, and I get y equals 33. So the two numbers are 45 and 33. anytime you have a word problem, you should write your answer in words just so it coincides with the actual structure of the problem. 5, 6, and 7, it says, what is the solution to the system? What method is best to use? Substitution, elimination, or graphing? So if I look at the way that my system is structured for number 5, this is a good question to use with elimination. Number 6, I'm going to do substitution. And number 7, I'm going to do elimination again. Now, when I'm deciding to use elimination, what I'm looking for is I'm looking for my x's and y's to be pretty much stacked on top of each other so that they are on the same side of the equal sign. From there, I can go ahead and create the same number and opposite signs for one of my variables. So if I look at my x, for instance, my x for my first equation is a 1x. My second equation is a negative 2x. So I can go ahead and multiply this first equation by 2. That way, I have a positive 2x minus 6y equals 4 for my first equation. And for my second equation, I can go ahead and just rewrite what I have, and if you'll notice, my x's now have the same number and opposite signs, so they can eliminate. Oh, look at this. Your y's are also going to eliminate. It's a lovely coincidence. So that leaves me with nothing on the left and 6 on the right. So since all of my variables did cancel out, I have two options. It can either be no solution or infinite solutions. Now, if I look at what I'm left over with, I have 0 equals 6, which is most definitely not true. So that is going to result in a no solution type of scenario. So that means if you were to actually graph these two lines, they would end up being parallel lines. So no solution for this one. For number 6, I'm going to do substitution, and the reason why I chose substitution is because I have an isolated variable. I have x by itself. So I have x equals y plus, or 2 plus y. So what I can do is I can literally substitute one equation into the other. So I'm going to go ahead and rewrite my second equation, but as I'm doing that, instead of x, I'm going to replace it with 2 plus y. What I'm trying to do is I'm trying to get it down to one equation with one variable, since we know how to solve those. From here, going to distribute, that gives me negative 6 minus 3y plus 3y equals negative 6. I can combine my like terms. Negative 3y plus 3y, well, that cancels out again. So I have negative 6 equals negative 6. That is actually a true statement, which means we have infinite solutions. So if you were to graph these two lines, they would end up being the same exact line stacked right on top of each other. So there's an infinite amount of intersection points between those two. All right, number 7. Let's see, using elimination again, just because my x's and y's are stacked on top of each other, they're on the same side of the equal sign. So what I want to do is I want to either eliminate my x's or my y's. I'm going to go ahead and take my bottom equation and multiply it by negative 2. And the reason why I'm doing that is because I want to change this 5 to a negative 10, so I can cancel out with this positive 10. So I'm going to rewrite my first equation since we didn't do anything with it. For my second equation, I'm going to multiply everything by negative 2. So that gives me 4x minus 10y equals negative 6. Now my y's are all set to eliminate. X's do not eliminate this time, which is nice, so we can actually solve. But I can combine them, so negative 3x plus 4x is 1x equals negative 4. So we have x equals negative 4. In order to solve for y, I can plug it into either equation, the first or the second one. I am going for the first one for no particular reason, just because that is where my brain told me to go. From here, I can subtract 12 from both sides. That gives me y equals negative 10. So y equals negative 1. Final answer should always be written as an ordered pair, x and then y. So these two lines would intersect at the point -4, -1 if you were to actually graph them. Okay, Mary took her family to the movies and bought 7 tickets for a total of $51.50. Adult tickets cost $12 and kid tickets cost $5.50. How many kid tickets were purchased? So first thing I'm going to do is I'm going to start by identifying my variables. I'm going to let X equal the number of adult tickets, and Y will be the number of kid tickets. Now they bought a total of 7 tickets, so that means when I take my adult tickets plus my kid tickets, gives me a grand total of 7. And it was for a total of $55. An adult ticket cost $12. So I have 12x plus child ticket costs $5.50. So $5.50y equals $51.50. Okay, now from here I need to solve my system. So you can solve for, you can use elimination or substitution. I'm going to go with elimination again just because my variables are stacked nicely on top of each other. I'm going to go ahead and eliminate my x's. Yeah, I'm going to go ahead and eliminate my x's because it says how many kid tickets were purchased. So I want to go ahead and actually just solve for y right away. So I'm going to take my first equation and I'm going to multiply it by -12, and then that's going to eliminate my x's. I can go ahead and rewrite, which I'm going to do over here. So I have -12x minus 12y equals -84. My second equation, I'm just going to rewrite because we did not multiply it by anything. Whoops, 51.5. Have this random line right here that I'm going to erase. And now my x's are all set to eliminate. For my y's, I can go ahead and combine both of those. So that gives me -12 plus 5.5 is -6.5. And -84 plus 51.5 is -32.5, and divide both sides by -6.5. So that gives me y equals 5. So that means there were 5 kid tickets that were purchased. Now, if you did end up solving for x first, like you eliminated to your y's, you would just have to take that answer and plug it back in to be able to solve for the other variable. For number 9, it says write a system of equation that represents this scenario. Your teacher gives a test with 24 questions. Each question is either worth 4 points or 5 points. Total point value of the test is 100 points. So I'm going to start by identifying my variables. X is going to be the number of 4-point questions, and Y is going to be the number of 5-point questions. So when I add X and Y together, that should equal 24 because there's 24 questions. So I need an X plus Y equals 24. So the only answer choice that has that is letter B. But I do want to double check that my second equation makes sense. It is 4 points for one type of question, 5 points for the next type of question, and the total is 100 points. So 4x plus 5y equals 100. So that works. Number 10, you are selling pencils to raise money for student council. Your goal is to raise more than $300. You earn 65 cents for each pencil you sell. What is the fewest number of pencils you can sell and reach your goal? So it is 65 cents per pencil. So I'm going to write 0.65x, and we want to raise more than 300. So I'm going to go ahead and set that up as an inequality. I can continue to solve for x, so I can divide both sides by 0.65, and then I end up with x is greater than 462. So that would be the fewest number of pencils that we can buy in order to reach our goal of $300. So the answer for that is going to be letter D. All right, continuing with inequalities. The first one says, which point is a solution to the linear inequality? So what I'm going to do is I'm going to take each one of these points and plug them in just to see if it works for my inequality. So for this first one, I am plugging in 0, 0. So I have 0 is less than or equal to 5 times 0 minus 3. That tells me that 0 is less than or equal to negative 3, which is not true. So this one does not work. Now I'm going to go ahead and plug in for letter B. I have 4 is less than or equal to 5 times negative 2 minus 3. So 4 is less than or equal to negative 10 minus 3 is negative 13. Again, doesn't work. So let's go ahead and plug in C. So I have 1 is less than or equal to 5 times 1 minus 3. That tells me 1 is less than or equal to 5 minus 3, which is 2. That is actually true. So my answer is going to be letter C. But let's double check that D doesn't work either, just in case I made a mistake somewhere. So I have 4 is less than or equal to 5 times 1 minus 3. That's telling me that 4 is less than or equal to 2, which does not work. So correct answer is C. If you wanted to, you could graph this particular inequality, which is, I'm assuming, why that graph is there. But in order to graph it, I can go ahead and find my slope and my y-intercept. So m is 5, y-intercept is 0, negative 3. I'm going to go ahead and start at negative 3. And I'm going to go up 5 over 1, up 5 over 1, 1, 2, 3, 4, 5, lost my count. And for inequalities, you do need to distinguish between whether you're going to have open circles or closed circles. This one, as I was plotting points, I had closed circles because my inequality had the or equal to. And since I have closed circles, I can go ahead and graph a solid line. Okay. Now, in order to shade, so whenever we're dealing with inequalities, we need to shade an area. And in order to shade an area, we need to figure out which portion actually has solutions. So you can do this one of two ways. You can use a test point, which usually I use 0, 0. Or, since it is in slope-intercept form, since this says less than, it tells me that I would shade underneath my line. So that would be everything going down. So then I can go ahead and shade this area of my graph. If it were greater than, then you would shade above the line. From here, you can go ahead and check to see if these points for A, B, C, and D are in the shaded region, and the only one that is in the shaded region is that 1, 1. Okay. Number 12, you want to buy at least 6 bags of candy, but you cannot spend more than $15. Bags of Skittles cost $1.50. Bags of chocolate cost $3. Define the variables and to write a system of inequalities to find how many bags of Skittles and chocolates you can buy. Do not solve. So I'm going to let x equal the number of bags of Skittles. Whoops, I spelled Skittles wrong. And y is going to equal the number of bags of chocolate. Let's see, I want at least 6 bags total, so that would be x plus y is greater than or equal to 6, because I want at least 6, which means I could have 6, I could have 7, I could have 8. So all of those are greater than or equal to, but I cannot spend more than $15. So $15 is the maximum that I can spend, so I need to spend either $15 or less than that. That's why I drew a less than or equal to. The bag of Skittles costs $1.50, so I have 1.5x, plus chocolates is $3, so 3y is less than or equal to 15, and there's your system. And it says don't solve. You would have to graph it anyway in order to solve. When graphing linear inequalities, what determines a solid or a dotted line? So if I have less than or greater than, that is going to create open circles with a dotted line. If I have less than or equal to, greater than or equal to, that's going to create closed circles with a solid line as you're graphing. Essentially, the dotted lines and the open circles basically mean that you do not include those values. So when you have that or equal to, you can include those values, which is why you would have a solid line. Okay, last set of problems. Graph the system of linear inequalities. So I'm going to go ahead and do this first one. X is greater than or equal to -2. I'm going to go to -2 on my x-axis. This is going to be a closed circle because it has the or equal to. And anytime I have x in a number, that's going to create a vertical line. Now for figuring out where to shade, it says x is greater than or equal to -2. So values that are greater than or equal to -2 would be everything to the right of that line. So I'm just going to draw little arrows to indicate that that is where I would shade. I'm not actually going to shade yet, just because I do still need to graph my other line. This one says y is less than 1. I'm going to go to 1 on my y-axis. Y and a number is going to create a horizontal line, and I am making this one dotted because it does not have the or equal to. And all the values for y that are less than 1 would be everything that's underneath it. So your final shaded region is going to be where your two arrows are pointing towards each other. So it's your overlap for your shaded areas. That is going to be this portion of the graph down here. And name a solution to the system. You can name any point that is either on the solid line or in the shaded area. I am going to go with the point 5, -5. That point is right here in my shaded area. All right. This inequality is already in slope-intercept form, so my slope is 1, my y-intercept is 0, 6. So I can start at 6. This one's going to have closed circles with a solid line because it has the or equal to. So I can go ahead and draw my solid line. Again, use a straight edge or just be very, very careful. And since this is less than, and it's in slope-intercept form, I know that I would be shading underneath this particular line. For my second line, this actually isn't in slope-intercept form yet. I like to get everything in slope-intercept form just because that's how my brain processes stuff. So I'm going to go ahead and subtract x from both sides. That gives me y is greater than -1x minus 3. So my slope is -1, y-intercept is 0, -3. So I'm going to start at 0, -3. This one does not have the or equal to, so that's going to be open circles with the dotted line. Slope is -1, so I'm going to go down 1 over 1, down 1 over 1, and again, I'm going to go ahead and make my dotted line because this one did not have the or equal to. And since my inequality is a greater than, I would be shading everything above this line. Now, this whole inequality trick only works if it is in slope-intercept form. Otherwise, you would have to pick test points. But both of these, I did change it into slope-intercept form, so I can go ahead and use my little trick where greater than is above and less than is below. I am going to shade the area that my two arrows are pointing towards each other in, and that is your solution area. So again, when you're picking any type of solution, it could be anything on a solid line or in the shaded area. I am going to pick the point 6, 10, which is over here in my shaded area. All right, so that concludes the Unit 4 portion of your final exam review packet.